branching. We'll start out with looping. We'll look at for loops, while loops, and do while. Then we'll talk briefly about the break and continue statements, and we'll conclude with a discussion of branching in C. In particular, we'll look at if else, and the if-else if, as well as the switch statements. So let's start with a hypothetical example. Let's assume we want to compute the factorial of a number. In particular, we're interested in computing the factorial of 5. So based on what we've learned so far, we can write a program such as the one I have on the screen. So I've got a variable answer, which is an integer, and it holds the computation 5 times 4 times 3 times 2 times 1, which you'll recall is the factorial of 5. And the second statement is a printf, which we've also met. And this simply prints out the answer. And if all is well, we will get an answer of 120. So this program's great, and you can type it in and run it and confirm it. But what if we wanted to compute the factorial of, say, 10 or 15 or some larger number? We would have to go in and write an even longer expression here. So here's one very simple example where we might want to consider a loop. In fact, I've rewritten this program to compute the factorial of 10 using a simple for loop. And you'll see the for statement down there starting with the keyword for, and I have a loop control variable I, which I initialize, and I have a condition that checks as long as it's less than or equal to 10, it will keep iterating, and finally my increment statement. And inside the body of the loop, I have answer equal answer times I. So this statement is going to repeat itself as many times as that loop iterates, and then finally it prints out the answer. So here's a simple example of where I might want to use a loop, and in particular, we're looking at the for loop. So let's take a look at these different looping constructs in more detail and check out the basic syntax. So for loop, as we've seen in the previous example, has several things that are needed. It has a initialization expression. So in that expression, we're typically going to initialize the loop control variable. Then we have a loop condition, and this is what executes at the top of the loop every time to see whether or not another iteration should proceed. So as long as the condition is true, it will continue. Then we have the a loop expression, which is basically the increment. So after the loop condition is done, the loop expression is going to execute. Then within the for loop, we're going to have a program statement here, and that could be a single line of code, or it could be a block of code. And when we say a block of code in C, we're talking about code delineated by the open curly bracket and the close curly bracket. Now stylistically, if you only have one statement in a for loop, you don't really need the open close curly bracket. But I would strongly encourage you to always use it just to make sure your logic doesn't get messed up. Your for loop might initially have a single statement in it, but later you might modify your program and forget to add the curlies, and you'll get some unexpected consequences. So from a stylistic perspective, I always add the curly braces in my loop constructs. So here's a simple example. I've got a loop, in a loop control variable of I, and we initialize it to 10. And then we say while I is greater than or equal to 0, we execute the statement, which is a simple printf printing out the value of I. Then we do the loop expression, which is the I minus minus, and check the condition again. So this code here is simply going to print 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, followed by the statement right after the loop, which is blast off. We also have a while loop in C. The syntax is shown here. We say while, and then in parentheses we put a Boolean or a logical expression, and just like with the for loop, we can have a single statement or a block of code delineated by open close curly braces. So here's an example, and you'll notice that this code does precisely the same thing as the previous example. I start with a variable count, or CNT, equal 10, and I print this variable out in consecutive iterations until until count is less than or equal to 0. So functionally, it does the same thing. So we could really use for and while loops interchangeably, and I've shown how to do that. So we could take a for loop and we could rewrite it to the equivalent while loop. So right before the while, we'd have our initialization expression. Then we would have our while with a loop condition and the program statement followed by the loop expression at the very end of the while loop, and that would basically give us the same result. There's also a do while in C, and this opens with the keyword do followed by a program statement or a block of statements, and at the very bottom of the loop we actually have the while loop. So once again, here's an example that I've taken our running example and re-implemented it as a do while loop. So notice in this construct, the loop is always going to execute at least once. Now, in addition to these looping constructs, we can also use the break and continue keywords. If we put a break statement, just break followed by a semicolon, somewhere inside a block of code associated with a loop construct, what the semantics are is it instructs the runtime to break out of that loop. So wherever we are in that loop and whatever the loop conditions are, the break statement will cause us to basically assume that that loop is finished and execution will resume at the first statement following that loop construct. Now continue can also be used to modify the control of a loop. So if we have a continue statement, so just continued followed by a semicolon within a loop, within a code block associated with a loop, it's basically going to bypass the rest of the code in the block. So everything following that continue statement will be bypassed, and we will return to the top of the loop and begin the next iteration. Now these two constructs are available, but you do want to be careful that you don't abuse these. If you use the break and continue statements liberally within your loops, the code can become very hard to use. And in a certain sense, it's very similar to using a goto statement, which of course you know is frowned upon by serious programmers. So let's take a look at branching. So we've got essentially two ways to branch in C. We can use if and else statements or if-else if statements, and we can also use what's called the switch statement. So the if statement comes in several flavors. In flavor 1, we can simply say if some expression and then a program statement or a block of statements, and that's the end of that. In flavor 2, we can add a else clause. So we can say if expression, then do program statement 1 or block 1, then we can put the keyword else followed by another statement or block of statements. So the semantics here are if the condition, if the expression is true, it'll do the first block. If it's false, it'll do everything following the else statement. In flavor 3, we have the if expression 1 and then some code. Then we can add the keyword or words else space if in a second expression, and we can continue that on as much as we want. So we can have many else if statements in one of these constructs, and then finally we can also add a else statement on the very bottom. So the semantics here are if expression 1 is true, it's going to do program statement 1. Otherwise, if expression 2 is true, it's going to do program statement 2. And if neither of those are true, then it's going to do program statement 3. And keep in mind that each program statement here could be a single statement, or it could be a block with multiple statements in it. And once again, I always use the open curly, close curly brackets in my if statements as well as the loops, as I've mentioned previously. And finally, we have the switch statement. Now the switch is somewhat similar to the if-else if. So with switch, we can say keyword switch and then some expression, some logical expression that we want to evaluate. And then we can enumerate all the different values that expression might take. Sorry, it doesn't have to be a logical expression. It could be any type of expression. And the values that that expression can take on are going to be enumerated. So in this case, I've shown value 1. So I've got the keyword case space value 1 colon, then a program statement. And notice the break statement. This is absolutely mandatory here. If you didn't have the break statement on a particular case, execution will continue in the next case statement that follows it. So if you're using switch statements, be sure you keep those break statements right at the end of each individual case value. At the very bottom, you'll notice a default colon. If none of the values, if the expression doesn't evaluate to any of the values that we've enumerated in the various cases, then the default statement will execute. So the code within that default statement will then be executed. So let's take a look at some examples using loops and branching constructs in C. For starters, let's write a program that reads a fixed number of integer values from standard input and computes their average. So I'll call this program average underscore fix.c, and once again we're going to do some standard I/O here, so we'll include that, and we'll have a main that takes no arguments. Alright, so I'm going to use a for loop for this, so I'm going to have a loop control variable, and I'm going to read the number of numbers that are going to be averaged from standard input. So I'm going to define a variable to hold that, and I'm going to compute an average, so I need a running sum, and I'm going to also need to know how many arguments, well, actually the actual values that I'm reading in each iteration of the loop. So let's and then we're going to compute a average, so we'll have a variable for that, average float. And let's go ahead and print out a prompt to our user. How many numbers are to be read? And then we'll use scanf to read that in. So we're going to read a integer. And remember, we need to use the address of, and we'll store that in number of nums. Then we'll go into a for loop. So our initialization expression will be I equals 0. And while I is less than the number of nums, so I have a typo there, and our loop increment is I plus plus. So the first thing we're going to do is read a number, and we'll store that in value, and again we have to use the ampersand there, and we're going to go ahead and compute the total, and here we're going to do total plus equals value. So remember, that's equivalent to total equals total plus value. And we'll go ahead, just to confirm that we've read it, we'll print out a little prompt here that says read %d and pass it value. And that's the end of our loop. So this will basically read number of nums integers in and total them. So when we get out of here, we can now compute the average. So our average is going to be equal to the total divided by the number of nums. Now, those are both integers, and we're really interested in a floating point number here, so I'm going to go ahead and typecast. Technically, I only need to typecast one of these values, and the result of the expression will automatically get promoted to being a floating point number. But just for readability here, I'm going to typecast both of them, and the final statement here is to print out a message. So you read %d values average equals %f, and then I need to put in the values, so number of nums and average. And then the last thing I need to do is return okay, so let's see if this works. So we'll just say gcc average fix.c minus o average fix, and it compiled. So let's say we want to read 6 numbers. Say 1, 2, 3, 4, 5, 6. And sure enough, it read all 6 of those values and printed out the average. So let's do something a little bit different this time. Let's say we don't really know how many values we're going to read from standard input. Let's read until we hit standard input. So we're going to go ahead and do a while loop for this. So let's go ahead and start with the code we already got. So I'll compute that to, or I'll copy that average fix.c to average variable, and I'll pull that into my editor. And I'm going to add one more value here. So scanf, recall, returns us the number of arguments that it actually filled. So we can use that in our while loop. So we'll have a variable called vals read here. And then in our scanf, we'll get rid of this because we're just going to read until we hit a end of file or a 0 from scanf. So what we can do is say vals read equals scanf %d value, and then what we're going to do is replace this for loop with a while loop, and we'll say while vals read is greater than 0. In other words, as long as scanf returns us something greater than 0, we can actually continue in this loop. And now we're going to need to do an increment on this manually because we no longer have the for loop doing it. So we'll increment this, we'll accumulate, we'll print out the read, and then the last thing we need to do is read a value again at the end of our loop. So I'm going to go ahead and add vals read. Okay, so now I've rearranged this, and as soon as vals read returns 0, so when I hit end of file, when there's no more data to be read, I'm going to get a 0 back from scanf, which is going to cause my while loop to exit and my average to be calculated and printed out. So let's go ahead and try this one. So I need to compile, and there it is. So now I remove the prompt. So now it's expecting me just to enter some values. So go 1, 2, 3, 4, 5, 6. If I hit enter, it's read them, but notice it's still waiting for input because it hasn't hit end of file yet. So on my terminal window here on Linux, if I want to indicate end of file, I can hold the control key and press D. And when I do that, that's basically end of file, and the scanf will return with a 0, causing the while loop to exit. And you'll notice I've gotten the exact same value again here. Now let's try one more example here. Let's assume we want to skip over negative numbers. So I didn't enter in the negative ones here, but let's just say we wanted to add that constraint. So if somebody did enter a negative number, we wouldn't use that in the average. So let's pull up the same program again. And what we could do is we could add a statement right after the val's read. We could say if value is less than 0. So if we read in a negative number, then what we want to do is skip it. So we can say continue and close off our if statement. But notice at this point we're actually giving the same val's read back to the previous one. So we're going to go into an infinite loop if we just leave it at this. So what we really need to do is skip ahead to the next one by doing another scanf here. So if I say vals read equals scanf once again here, this will move us along to the next item on the input. So let's see if this works. Alright, so, oops, I've got a typo there. So we'll go and fix it. And this was line 12. Vals read. And if we run it this time, and once again, so we'll say 1, and let's say -2, 3, -4, 5, -6, and let's see what it does. So notice now it skipped the negative ones and only included the positive. So if I do a Control D for end of file here, now it computed the average only using the 1, 3, and 5, giving me an average of 3.